how are you all? I hope you are all are doing wonderful. So as you know, the JEE Mains first attempt is very near, and we have already started a JEE Main previous year question session, and today is the session number 5. And in today's session, we will be covering the last particular part of conic section, that is hyperbola. Alright, so if you are someone who is new to this particular platform and haven't started watching, then I would definitely recommend you to go to the playlist and start watching the JEE Main previous year question session. Alright, so I have already covered the chapters like straight lines, circles, parabola, ellipse, and this is the take on hyperbola. So with this, I will be covering the entire conic section. Alright, so and also I want to know from all of the students. Alright, so how is this particular playlist or this particular lectures are beneficial to all of you? Alright. So with this, let us start with the hyperbola. Alright, so today's goal will be on covering the chapter of hyperbola, and we will take up the top 10 important JEE Mains previous year questions. Alright, so hyperbola, and if you think of hyperbola, the chapter hyperbola has not very much of great weightage. Alright, so if there is a question on ellipse, you might not get a question on hyperbola. What I actually saw in the pattern of the paper was that hyperbola questions were actually asked in the numerical type fashion. So I took up the numerical question because in JEE Mains numerical question also plays a good role. Alright, so I will take in the orange color. Alright, so in this question it is saying that the foci of the hyperbola, okay, the foci of hyperbola, okay, are as, okay, plus minus 2 comma 0. Okay, so I have the two foci of the hyperbola which are basically plus minus 2 comma 0, and also have the eccentricity. I have the eccentricity that is greater than 1, and it is basically equal to 3 by 2. So for hyperbola, the eccentricity is greater than 1, and the eccentricity is basically 3 by 2. Now it is saying me a tangent, okay, a tangent of hyperbola, okay, which is basically perpendicular to the line, okay, perpendicular to the line 2x plus 3y is equal to 6. So from here, the slope of the tangent will be minus 1 by the slope of this particular line, and that is equal to minus of, and we see from here the line has a slope. So the slope of the line is basically minus of 2 by 3. So what will be the slope of the tangent? That is minus of 1 by 2 by 3. That is basically 3 by 2. So that's the slope of the tangent. Okay, so I got the slope of the tangent as 3 by 2. All right. Now, what is basically said? The foci of the hyperbola. So if it is a focus of the hyperbola, they are basically plus minus a comma 0. Okay, where the x-axis is the basically the main axis. Okay, or the principal axis. All right. So if it is this, then we have this is as plus minus 2 comma 0. So from here, I can get the value of a as 2 by e, and we know what is e. E is basically 3 by 2. So this will come as, that is a is basically 4 by 3. Also, I got the value of a. All right. Now, if I have the value of a, then I know the eccentricity equation, that is e square is basically equal to 1 plus b square by a square. Okay, 1 plus b square by a square. So from here, if I put the value of a and e, I'll get the value of b square as a square plus a square, sorry, a square e square minus, okay, so this will come out as a square e square minus of a square. So from here, I will get the b square value as, so from here, if I put the values, I will get the b square value as, so the b square value will be, this is 16 by 9. Okay, so 16 by 9 into 9 by 4 minus 16 by 9. Okay, so from here this will give you the result, that is 20 by 9. Okay, so if you solve this, this will come out as 20 by 9. Now if I have the value of b square, that means b square is equal to 20 by 9. Okay, so b square I have as 20 by 9. Now therefore the equation of hyperbola is, what will be the equation of hyperbola now? That is x square by a square. So a square, it is basically 16 by 9 minus y square by b square. What is b square? That is 20 by 9. Okay, and it is equal to 1. Okay, so that this is the equation of the hyperbola. All right. So I got to the equation of hyperbola. Now, what is said in the question? It is said that a tangent, okay, the tangent perpendicular to the line 2x plus 3y is equal to 6 is drawn at a point in the first quadrant of the hyperbola. Now, if the intercept made by the tangent on the x and y axis are a and b respectively, then you basically have to find out for the value of 6a plus 5 times of b, both have modulus on itself. All right. So we have to basically look for the intercept made by the tangent. That is basically formed by taking the equation of tangent. So writing the equation of tangent. Okay. So the what is the equation of tangent for a hyperbola? That is y is equal to mx plus minus root under a square m square minus of b square. So that's the equation of the tangent for that hyperbola. All right. So in case of ellipse, there was plus sign over here, but in case of hyperbola, you just replace it by negative sign. That's why I would recommend you whenever you're revising the chapter of hyperbola, I would recommend you to revise it with ellipse as well. Or better it should to take the parabola, ellipse and hyperbola together, because the questions are definitely mixed upon. All right. And with this you will get the value of the tangent, that is y is equal to, so we have the slope as 3 by 2, so 3 by 2 into x plus minus root under a square is basically 16 by 9 into m square is basically 9 by 4 minus b square is basically 20 by 9. Okay, 20 by 9. So from here you will get the equation as 3x by 4, sorry, 3x by 2, 3x by 2. Okay, the equation will be 3x by 2 plus minus. So if you solve this, this will come out. So 9 get cancelled, and 16 by 4 minus 20 minus basically 16 by 9, and this will come out as 4 by 3. Okay, so you got to the equation of the tangent. Now for getting the x-intercept or and the y-intercept, we basically have to put, so for y-intercept x is equal to 0. So y-intercept x is basically equal to 0, and the value of y-intercept is basically b, so that is equal to 4 by 3. Okay, so for both the tangents, the modulus value of the y-intercept will be 4 by 3, and similarly putting y is equal to 0, we get x-intercept. Okay, and this will give you the modulus of x-intercept will be equal to, so if you put y is equal to 0 and take this on the right hand side, the minus plus of 4 by 3 is equal to 3x by 2, and that will be equal to 8 by 9. Okay, so the modulus value will be equal to 8 by 9. Now I have to find for the value of 6 times of modulus of a, 6a whole modulus plus 5b whole modulus, and this will be equal to, so 6 into 48 by 9. Okay, so this will be equal to 48 by 9 plus, and this will be equal to 20 by 3. Okay, so you can do one thing, you can cross multiply the denominator and the numerator by 3 and get a 60 by 9, and 60 plus 48 is 108 by 9. Okay, so that result will be 108 by 9, and that is basically equal to 12. So with this you get to the numerical answer of this particular is basically equal to 12. I hope you are clear with this particular solution. Okay, so pretty simple question, but a decent standard question that can definitely be asked from the chapter of hyperbola. All right, so I will say this particular question is important because it is asking you for the basic properties of the hyperbola, and then it is asking you for the equation of tangent. Okay, because in conic section, equation of tangent and normal, they are very important. Okay, for question purpose. With this, let us move to the next problem. And the next problem is again a numerical type problem I got. Okay, for the important problems. Okay, so this problem is again on the concept of tangents. Okay, so it is saying that for an hyperbola, so the equation of the hyperbola is given as, okay, so this is an basically hyperbola which is given as y square by 25 minus x square by 16 is equal to 1. Okay, so this is basically the equation of the hyperbola. Okay, now it is said that from point P, okay, now let m1 and m2 be the slope of the tangent drawn from point P. So P is a point that is 4 comma 1. Okay, so from point P, two tangents are basically drawn to the hyperbola. Okay, now if Q is the point from where the tangent drawn to the hyperbola, both the slopes m1 and m2, and they make positive intercept alpha and beta on the x-axis. Okay, so both of the tangents makes positive intercept alpha and beta on the x-axis. Then you have to find for pq whole square divided by alpha beta. All right, so that is basically the question. Now for this type of parabola, which can also be written as x square by 16. Okay, so x square by 16 minus y square by 25 is equal to minus of 1. Okay, so this is basically not the normal hyperbola. This is the hyperbola which is drawn in this particular fashion. Okay, which is something like this. All right, so this is the hyperbola which is basically of this particular fashion, and it is saying that from point P, that is 4 comma 1, both the tangents of slope m1 and m2 are drawn. Okay, so one tangent is something like this and another tangent is something like this. Okay, so both of the tangents are drawn from one point, that is point P. So let me say this is a point P, So from point P, if the tangents are drawn, okay, so from point P tangents are drawn, okay, so from point P tangents are drawn, and both of the tangents have slopes, one as a m1 and other as a m2 slope, okay. Now for this particular parabola, hyperbola, which is basically equal to minus of 1, or if it is starting with the y square minus 25, okay, so for this kind of hyperbola, all right, so we basically get to the equation of tangent as y is equal to mx plus minus root under a square minus b square m square, okay. So for this parabola, for this hyperbola, we have the equation of the tangent as of this particular fashion, and we already know the values of a square and b square, so we can definitely plug in the values of a square and b square to get to the parabola, to get to the tangents as y is equal to mx plus minus root under, that is this will be 16 minus 25 m square. Now if this particular tangents pass through, okay, now this particular tangent pass through the point P, that is 4 comma 1. So if we satisfy 4 comma 1 in this particular tangent equation, then this will give me a quadratic in M. That means it is saying that there are basically two tangents or two slopes of tangents are possible. So let me put and get to the quadratic. So if I put the equation, so let me put over here only. All right, so y is equal to 1 and m is equal to 4, sorry, x is equal to 4. So 4m plus minus root under 16 minus 25 m square, okay. So from this particular we get the value 4m minus 1, 4m minus 1, and then we take the square, and this will be equal to 25. Sorry, there's a mistake from my side, okay. We considered a in this particular situation, this value as a, okay. So with the y square coefficient we considered as a, so this is actually okay, so my mistake. All right, so yeah, that's all about formula. So how well you remember the formula is the thing that you must remember, okay. Because okay, it might create confusion as well, okay, sometimes it creates confusion for me as well. All right, but yeah, if you are someone who has revised the chapter, then you must not have this particular type of confusion. So that's my take, that you have to go on continuously revising the entire chapter, then only you will be understanding this particular minute details, okay, that which to consider as a and which to consider as b in different cases, okay. But this particular situation doesn't arise for the like case of ellipse. But whereas in ellipse we basically have major axis and minor axis concept. All right. So here also we have major axis. All right. Now with this let us move, and this will be basically 25 minus 16 m square. Okay, 25 minus 16 m square. And from here, if I solve it, this quadratic will become. So if I solve this quadratic will become. So 16 m square. Okay, so 16 m square plus 1 minus and minus of 8m is equal to 25 minus 16m square. So if you take this on this particular side, and then if you form the quadratic, so you can simplify then get the quadratic as 4m square minus m minus 3 is equal to 0, because this will become 24 and this will become 8 only. All right. So with this you can simplify them and get as 4m square minus m minus 3 is equal to 0. So from here you basically get the two values of m, that is the first of the slope is basically equal to 1 and other slope is equal to minus of 3 by 4. Okay, so you can factorize this easily. So this factorize will be 4m plus 3 into m minus 1 is equal to 0. So from here you get the roots as 1 and 3 by 4. Now it is saying that if q is the point from which the tangents drawn to h have the slope modulus of m1 and modulus of m2, and they make, okay, so we basically need to get the, so if m1 mod is 1 and m2 mod, or taking the absolute value, it is basically 3 by 4, okay. So then the equation of tangents become, then the equation of tangent, so for the slope as absolute value of them, then the equation of tangent, one of the tangent will become y is equal to sorry, in place of m by putting 1, so this first tangent will become, it will become, so if I put in place of x, if I put 1, then it is x minus 4, x minus 3, sorry, this is the first tangent, and the second tangent will become 3 by 4 x minus, so if you calculate that, that will become 4, okay. So this is the second tangent, okay. So I got to the two tangents, okay. So I got to the two tangents. All right. So if we have the two tangents, then we have to look for the intercept. So for this intercept, okay, so it is saying that these basically tangents are basically drawn from a point Q. Okay, so these particular tangents are drawn from a point Q. So these particular tangents are drawn from a point Q. That means the intersection point of this. So intersection point is Q. Okay, so intersection point is Q. So let us solve for the intersection point. Okay, so if we put both them of the things are equal, so this will be equal to 3 by 4 x minus 4. So from here you get it as, okay, so if you take this on the left hand side, this will be x by 4, and if you take this, and then this is equal to minus of 1. So from here x is equal to minus 4, and if I put x is equal to minus 4, so y is equal to minus 7. Okay, so I got to the point Q as minus 4 comma minus 7. So I got the point Q as minus 4 comma minus 7. Therefore pq whole square, okay, because I have to look for pq whole square as well. So pq whole square, that is a square the distance, is basically equal to, so p is 4 and q is minus of 4, that is 8 square plus, and p has a y coordinate 1 and q has a y coordinate minus 7. So 1 minus of minus 7, that is 8, again 8 whole square. So this will become 160, 64 plus 64, that is 128. Okay, so this is 128. Now I have to look for the x coordinate x intercept of both the tangent. So if you can see from the both the tangent, so the first tangent has the x intercept, that is a value as alpha, so it will be equal to 3, and the second one has x intercept as value as beta, so this will be equal to, by putting y is equal to 0, this will be this value as 3 by 16. Okay, so these are the x intercept. Okay, I hope you have read the question. Okay, so this is the x-intercept. So it is said that x-intercept are positive and that are basically alpha and beta on the x-axis. So I got to the values of pq square, and I also have the value of alpha beta. So from here the result, that is pq whole square divided by alpha into beta, is basically 128 divided by, so p is 3, alpha is 3 and beta is 3 by 16. So with this, if you solve this, the result will come out to as, okay, oh sorry, very sorry, this is not, beta is basically 16 by 3. Okay, very sorry, very sorry. So from here the beta value will be equal to 16 by 3. Okay, so beta value is basically equal to 16 by 3, and with this the result will be, okay, so the result will be, from here 16 by 3, and if you cancel 3 and 3, and this will be 16 times, and if you see this is 16 8s are, so 16 8s are 128. That means the answer or the result of the numerical type problem is basically equal to 8. So the result will be equal to 8. I hope this particular problem is clear. All right, so this is pretty simple problem on the numerical type. All right, so with this, let us move to the numerical MCQ types of problem, and the very first problem on the screen we have is this particular problem. Okay, so we need to start solving this particular problem. Okay, again I would request you to just pause the video and start to solve the problem on your own. So with this, let me start solving. So the question reads as, okay, so we have a R as a rectangle which is formed by the lines x is equal to 0, x is equal to 2, y is equal to 0, and y is equal to 5. So let me first draw the rectangle. Okay, so if you draw the rectangle, so this is x and this is y. So if you can try to draw the rectangle, so one of the rectangle has, one side has the y-axis and other side has the x-axis, and one side has x is equal to 2, so x is equal to this line, and y is equal to 5 is this particular line. Okay, so x is equal to and y is equal to, so x is equal to and y is equal to 5. So this is the rectangle. Okay, so this is the rectangle. So let me label this rectangle as, okay, instead of A B C, I am using P Q R, that particular notation. So the rectangle will have the coordinate as P Q R and S. Okay, so this is the this is a rectangle. Okay, so I write this as P Q, sorry, P Q R S, P Q R S is a rectangle as mentioned in the problem as rectangle R. Okay, so it is a rectangle R, and let alpha, so alpha is a point. Okay, alpha is a point, that is alpha, so A is a point, that is alpha comma 0, and B is a point, that is 0 comma beta. Okay, so B is another point, that is 0 comma beta, and it is saying that it is mentioning the range of, so alpha belongs to, okay, alpha belongs to 0 and 2 both in the close bracket, and beta basically belongs from 0 to 5. Okay, so it is saying for the alpha and the beta range. Okay, Now it is, that means the alpha basically point is basically lying inside this PQ line, okay, line segment, and beta, that means basically lies inside this line segment PS. That means from this particular point it is saying that the line segment AB, so I can consider line segment something like this fashion. Okay, so I can consider this as the point A and this is point B. So the line segment AB, so line segment AB divides the area of the rectangle in the ratio 4:1. So if we see that the line segment AB divides the area of the rectangle in the ratio, so this particular area, okay, this particular area and the, let me highlight the rest area. Okay, so this area is basically 4 times of the smaller area. Okay, so this larger area is basically 4 times of the smaller area. Now how will we solve for this particular situation? So the area of of so this will be a rectangle, so this rectangle is PBA is to area of the quadrilateral form. Okay, so this will be the remaining part will be a quadrilateral, that is AQRNSB. Okay, so not a quadrilateral, or basically it is basically 1 2 3 4 5 sides, so it is basically a pentagon. Okay, not a pentagon, pentagon is a regular figure, sorry. So it is a five-sided figure. Okay, five-sided figure. And so from here, this particular figure, then the ratio basically given of the ratio is basically 1:4. Okay, so this is the ratio which is mentioned in the problem. So it is saying that the line segment AB divides the rectangle in the ratio 4:1. Now we have to find for the midpoint. Okay, so we have to find for the midpoint. All right. So every time we divide, every time for varying the point for different points of alpha and beta, so as long we go on varying the point alpha and beta, we get different sets of possible line segment AB. And for different segment of line segment, the only thing that is constant, that is basically the division of the area. Okay, so the area is basically divided in the ratio 4:1. So you have to look for the midpoint of AB. So if you can say this is point B and this is point A, that is alpha comma 0, and point B is beta 0 comma beta, so what will be the midpoint? So let me write the locus of the midpoint as H comma K. Okay, because we, after all, we have to find for the locus, because it is saying the midpoint of AB lies on what particular curve. So let the locus be, okay, so let the locus be H comma K. All right, so if this particular locus is H comma K, now what I can do, firstly get to the area of the rectangle. Okay, so area of the rectangle, that is R, is equal to 2 into 5, that is basically equal to 10 square units. The area of the rectangle is basically 10 square units. Okay, now what will be the area of the triangle? What will be the area of a triangle? Area of triangle PAB, that will basically have 1/4%. Okay, that means basically 1/5 of the, sorry, it is divided in the ratio 1:4. That means 1/5 of the area of the rectangle. So that is 1/5 of the area of the rectangle, that is 10, and that will be equal to 2. And we already know the area of the rectangle, sorry, triangle is basically half into base into height. So this is alpha into beta. So from here I get the value of alpha beta. So from here I get the value of alpha beta as 4. Okay, so I got to the product of the alpha beta, and let it be equation number 1. Now we know that the midpoint has basically the locus of the midpoint, or the midpoint basically has the coordinate h comma k of AB. Okay, so this is the midpoint of AB. Now what we can do, for h value this is basically equal to alpha by 2, and for k value this is basically equal to beta by 2. All right, because by using the midpoint formula, and if we can use this, then from here alpha is basically equal to 2h and beta is equal to 2k. Now what is the value of alpha into beta is 4. Then I can substitute this back into this particular equation, and I get the equation as h into k. 4h into k is basically equal to 4. That means hk is equal to 1. So from here, what can be the equation of locus? So equation of locus is basically, so if we can see, this is the locus equation. So the locus is basically h into k is equal to 1. So that will give you x into y is equal to 1. Okay, x into y is equal to 1. All right. So which is basically a rectangular hyperbola. Which is basically rectangular hyperbola. That means this is a problem on not on hyperbola, but this is general problem on coordinate geometry, which basically wants to find out the locus. Okay, so that means the midpoint of the line segment, the midpoint of the line segment AB basically is lies on the hyperbola. With this, the right answer will be option number A. Okay, so with this, the right answer will be option number A. I hope you have got this particular solution. So let us move forward and let us start solving the other important problems. Okay, and the second important problem I got is basically another important problem which is another question on the tangents. All right. So let me understand this firstly the question. It is saying that the point P, that is x naught and y naught, is a point on the hyperbola. Okay, so the equation of the hyperbola. So let me write the equation of the hyperbola as x square by 12 minus y square by 9 is equal to 1. So that's the equation of the hyperbola. Okay, now it is saying which is nearest to the line. Okay, P is a point on the hyperbola which is basically nearest to the line 3x plus 2y is equal to 1. Okay, so what I can see, so if I draw the situation, then this is a very important type of problem. This type of problem actually get repeated. Okay, so if you look at this problem, so if this is the x-axis and this is the y-axis, okay, and you can see that this particular point is equal to um, this is equal to 2 root 3, okay, and similarly this point is basically equal to minus of 2 root 3. Okay, so this is the hyperbola. Okay, now it is saying that the point P is P be the point on the hyperbola. So P is a point on the hyperbola, that is x naught and y naught. Now which is nearest to the line. So there is a line 3x plus 2y is equal to 1. Okay, now 3x plus 2y, that will basically it will have the x coordinate as 1 by 3 and the y coordinate as 1 by 2. So some line like this. Okay, this fashion. So I can draw this line as this particular fashion. So since we are not very sure where the P point line, the P point may light be over here. Now if this particular point is this minimum, that means basically if this particular point is minimum from the line, then it must be on the, then it must have this particular distance as minimum. Okay, this distance as minimum distance, and I have already covered you, but also you, if you have studied the entire syllabus in the chapter of application of derivative, you must have understood that the shortest distance always occur along the common normal. All right, so for this particular straight line, and this point particular curve, or any random point on a curve, these particular points are basically will be we have the minimum distance when the tangent at that particular point on that curve is basically parallel to the given line, will be parallel. That means if I draw a tangent at point P, now these tangents, if they are parallel, because this particular line obviously lies on the normal of each other. All right, what do I mean by this? Because if I say that a point P is nearest to the line 3x plus 2y is equal to 1, then basically I already talked about the shortest distance always occur along the common normal. So if these are normal, then if we draw a tangent at point P, that this particular tangent will be parallel to the line from where I am taking the distance of. Okay, so this is a very simple concept, and you must remember this type of concept. That means if I draw the equation of the tangent, if I draw a tangent at P, so what will be the equation of tangent at point P? This will be x naught by 12 minus y into y naught by 9 is equal to 1. So this is the equation of the tangent at point P, and also the line is basically 3x plus 2y is equal to 1. So from here, what I can say, the equation of this line, the slope of this line is basically equal to minus of 3 by 2. And if it is minus of 3 by 2, then the equation of tangent at P will be parallel to it. That means the equation of tangent at point P has also the slope is equal to minus of 3 by 2. And if I look for what is the slope of this tangent at point P, what is the slope of the tangent at point P? So you will say that the tangent of the point P, so the tangent value at point P is equal to, so you can see this is equal to x naught by 12 into 9 by y naught, and that is equal to minus of 3 by 2, and that is equal to minus of 3 by 2. Okay, so from here the result will be 3 by 4 times of x naught by y naught is equal to x naught by y naught is equal to minus of is equal to minus of 3 by 2. Okay, will be equal to minus of 3 by 2, minus of 3 by 2. So from here the result will be, if we cancel out 2, the x naught by y naught is equal to minus of 2. Okay, because 3 and 3 get cancelled, and x naught by y naught is equal to 3 by 2. All right, now what I can write, I have to basically somehow get to the value that is y naught and x naught. Then only I will be able to calculate root 2 times of x naught minus x naught. Okay, y naught minus x naught. Okay, so let us now, if we have the slope of the tangent, then I can also write the equation of tangent in slope format as, so equation of tangent in slope format. Okay, slope format will be equal to y is equal to mx plus minus root under a square m square minus b square. Okay, so this will be equal to y is equal to, so in place of m I will put minus of 3 by 2 x plus minus. Okay, so in place of a square it is basically a square is basically 12 and b square is equal to 9, so 12 m square, and if you calculate this, the result will be, so you can calculate the result will be coming out as 3 root 2. Okay, so the result will be basically 3 root 2. You can solve this on your own. Okay, so the result will be basically 3 root 2. So 3 root 2 will be the result. And if I have 3 root 2 as other one of the tangent, okay, as this is the tangent at point P, so let me write the equation number 2, because since the tangent at point P is basically also the equation number 1, okay, and also it is the equation number 2, that means on comparing equation number 1 and 2, on comparing 1 and 2, what I will get? I will get to the coordinate. That is, if I compare the x coefficient and y coefficient, that is x coefficient x naught by 12 and the x coefficient for here, it is basically 3 by 2. Okay, or if you cross multiply 2 also, then it can be basically 3. So let me write the equation of the tangent in the proper format, that is 3x plus 2y is equal to 6 root 2. So this is the equation of the tangent at point P with a slope 3 minus of 3 by 2. So then comparing the coefficient, okay, 1 and 2, that is x naught by 12 by 3 is equal to y naught by minus of y naught by 9 by 2 is equal to 1 by 1 by 6 root 2. So from here, if you can see, then if you evaluate the first this particular form, then you get the x naught value, and that is equal to, x naught is basically equal to 3 root 2. So x naught is basically equal to 3 root 2, and y naught is equal to, minus of 3 by root 2, and y naught is equal to minus of 3 by root 2. So y naught and x naught, I got to the both of the values, and if I have both the values, then I can easily calculate the result of the expression, that is root 2 into y naught minus x naught, and that is basically root 2 into, so what is the value of x naught? X naught is basically y naught is basically minus of 3 by root 2, so this will be minus of 3 by root 2 minus 3 by root 2. Okay, minus 3 by root 2. So if you can see, if you multiply by root 2, this result will be minus 3 minus, so this will be minus 6. So the result will come out as minus of 9. With this, we have the right answer as the option number B. I hope this result is clear. Alright, this is a pretty simple question. I hope you have got this. With this, let us move to the next problem, and it is saying that, okay, now this is also an important problem on the concept of the transverse axis and conjugate axis. Okay, so for instead of like calling this major axis and minor axis, we basically call for hyperbola, we call them as transverse and conjugate axis. So it is saying that T and C respectively represent the transverse and the conjugate axis of the hyperbola. Now instead of giving you the general simplified equation of hyperbola, it is basically giving you a complicated equation, and it is saying that it is hyperbola equation is 16x square minus y square plus 64x, okay, plus 4y plus 44 is equal to 0. Now why did I take this question? Because many times you will also face this particular type of problem, and what is the approach to solve this type of problem, you will have to learn from this particular solution approach. Okay, now I will be teaching you, since this is the equation of hyperbola but there is no xy term, that means there is basically a possibility of clubbing the terms and making it a perfect square, and to get to the perfect square, and then we basically get to the general equation of the hyperbola with shifted center, I hope you have got to this particular thing, that what I'm talking of. So with this, let me club the equation, then 16x square, and let us club the x part, and 64x. Okay, so if it is 16x square plus 64x, okay, then it is giving me indication that is something as like 16 into x plus, so if you take a 16 common, this will be 4x, so it is giving me the indication that x square plus 4x plus 4. So if we have plus 4, that means basically 16, if we take common, that's plus 64. So if we have 64 over here, okay, so this will be 16 times of x plus 2 whole square. All right, and similarly if I take minus common, this is minus of y square minus 4. Okay, but since over here we basically, and we have 44 left out of here. Okay, since we added plus 64, we have to minus plus 60 minus 64, so minus 64, and over here it is 44. Okay, so if you see, then the balance, if you add a plus 4 over here, and the balance will be basically equal to 16, and the balance which is left over here is basically equal to 16. Okay, so with this you will get it as x plus 2 whole square, 16 times of x plus 2 whole square minus y minus 2, y minus 2 whole square is basically equal to 16. And from here I get to the general or the simplified version of the equation of hyperbola, that is x plus 2 whole square divided by 1 minus y minus 2 whole square divided by 16 is equal to 1. That is a general equation of the hyperbola, okay, which shifted center. Okay, now it is asking me in the area of the region above the hyperbola below the transverse axis and the right of the conjugate axis. So from here what I can say, what is the transverse axis? So from here if you solve this, the transverse axis of this particular for this particular transverse axis, okay, so if you look for transverse axis, so that is x plus 2 is equal to 0. Sorry, transverse axis is basically y minus 2 is equal to 0, okay, because for transverse axis is basically a line which is parallel to the y axis, okay, sorry, the y line which is parallel to the x axis, okay, that will basically give the transverse axis, okay, and that is basically y minus 2 is equal to 0. So from here I will get the transverse axis as y is equal to 2, okay, so I got to the line as y is equal to 2, and for conjugate axis, okay, and for conjugate axis, okay, this will get the line as x plus 2 is equal to 0. So that is the line of the conjugate axis, okay, you will get it as minus of 2, x is equal to minus of 2. Now what is the given equation of the parabola? Okay, now since also the question is asking me for taking out the area of the region inside the parabola, which is basically bounded by the transverse axis in the right of the conjugate axis, that is the parabola equation is x square minus 4 is equal to y. Okay, so let me first plot the parabola. So if you see the parabola, so if you plot the parabola will be a parabola which is opening upward, okay, and it will have the roots as plus 2 and minus of 2. So let me first get the parabola as like this. So and it will have the center somewhere around here on the y-axis. So it will be, okay, bad drawing. I'm trying to improve my drawing, but okay. So this is the parabola looking like this, okay. Now we have to find out the parabola, the area of the parabola which is below the transverse axis, and below the transverse axis there is y is equal to 2. So the line y is equal to 2 is this particular line. This is y is equal to, this is the equation of the hyperbola, that is y is equal to x square minus y x minus 4, okay, y is equal to x square minus 4, that is the equation of the parabola. And also which is left which is on the right of the conjugate axis. What is the conjugate axis? That is x is equal to minus of 2. So this is a conjugate axis. So we have to basically find out this particular area, okay, we have to find out this area. Okay, let me use some different colors. All right, it is not visible. I believe white is visible. Okay, white is not visible. Okay, whatever, so let me use my pen only, it is better. So this is the area of the, this is a required area we need to find for. So this is the area, okay, the area we have to find for. So let me write that area as A, okay. So what we have to find for this is basically the area. So in this question, it is a question on hyperbola. It's not basically a question on hyperbola or a parabola and hyperbola. It is basically a question on the definite integral. All right. But since you have to use the application of knowledge of the hyperbola as well as the parabola to get to this particular the definite integral. That means the area you will basically have it as the modulus of, because areas can always positive. So if you take area from, and what is the point at what it is cutting, it is minus 4, okay, it is basically minus of 4, okay. So if you take this, let me use the white color as well. So if you have to take for the integral, then we basically take it, let me find out this particular point of intersection, okay. Firstly we will take this particular area and add it with this particular area. All right, so that's what my idea is, it is to solve. Okay, so the equation will be basically minus 2 to what is the x coordinate where it is intersecting, it is basically equal to, so if you put x is equal, y is equal to, so x is equal to, x square is basically equal to 6, and if x is basically root 6, then from here, so this particular point will be root 6. So from here the integral will become minus 2 to root 6. So okay, so definite integral will have the limit minus 2 to root 6, and we have to upper curve minus lower curve. So what is the upper curve? That is y is equal to minus the lower curve. Lower curve is the equation x square minus of 4. Okay, so that is the integral function and dx, and then we have to take the absolute value. Okay, so this will be the, and the result will come out to s. So if you solve this, if you simplify, this is basically 2x minus, okay, or you can do one important thing, that is you add it and write it as 6x. Okay, so this will be, the value will become 6x minus x cube by 3, and if you put the limits, the lower limit is minus 2 and the upper limit is root 6. So if you put the limit and solve for it, okay, you will definitely find it. So let me solve over here. You can definitely get to the result as 6 root 6 minus 6 root 6 by 3. Okay, and then minus of, and if you put minus 2, then is minus of minus 12, minus of 8 by, that is minus of minus, that is plus of 8 by 3, and from here you will get the result as, the result will become 12 root 6, 12 root 6 by 3 plus 28 by 3. So you can solve this on your own and you get the result as 12 root 6 by 3 plus 28 by 3. So with this you get to the right answer to this particular problem, that is basically, so from here you can see, you saw that the answer is basically 12 root 6 by 3. So if you cancel it is 4 root 6. So 4 root 6 and plus 28 by 3. So which is the right answer will be option number C. So that is option number C is the right answer to this particular problem. I hope you have got this particular question. Okay. Now this particular problem is a problem on definite integral. But before finding out the definite integral, you basically need to have knowledge of hyperbola to get to the transverse and conjugate axis, as well as the knowledge of the parabola. So this is a pretty decent type of problem that can be definitely asked in your JEE mains examination. All right. So let us move to the next problem. All right, so the next problem, it is speaking of that we have an hyperbola. Okay, so the equation of the hyperbola, it is saying that x square by a square minus y square by b square is equal to 1. Okay, so that's the equation of the hyperbola, and it is saying it is passes through, okay, passes through the point 2 root 2 comma minus of 2 root 2. Okay, so it is a hyperbola which basically pass through the point 2 root 2 comma minus of 2 root 2. Now a parabola is drawn with the same focus as of the, sorry, a parabola is drawn with the same focus as of the focus of H. So what is the focus of H? Okay, focus of H is basically AE comma 0. Both the focus you can consider as AE comma 0. So one of the focus of H, okay, whose positive axis are, okay, with positive axis are, and the directrix of the parabola passes to the other focus of the H. Okay, so the other focus of the H will be minus of AE. Okay, so how can we solve this particular problem? That means for the parabola, that means if we draw the situation, it is somewhere of the fashion like this. Okay, so if you can visualize this as, okay, so you can visualize this as, okay, this is the hyperbola with the one focus at here and other focus, okay, so the other hyperbola and other focus is here. So it is saying that if the directrix of the parabola is on the other focus and the one of the focus is basically the focus of the parabola, that means the parabola is something like this. Okay, many students consider one branch of the hyperbola as a part of a parabola, but that is very wrong concept. Okay, don't understand this is a parabola in itself. Okay, one of the branch is a parabola. Okay, you will understand this particular thing if you look at the geometrical aspects. Okay, parabola is different because both of them have different equation. Okay, they are studied in different nature. If your drawing is in particular fashion, it doesn't mean this is a part of a parabola. It is actually a hyperbola. It is different. Okay, now we know that the equation of these types of parabola is basically y square is equal to 4ax. Okay, and now for this particular parabola we have basically what is basically a. So a over here basically represent the focus of the parabola, but in this particular problem the focus of the parabola is basically ae. So instead of writing a, we will basically write it as ae. Okay, so this will be a into e. So that is the equation of the parabola. Now we basically, it is saying that if the length of the lattice rectum of the parabola is e times the length of the lattice rectum of h. So what is the lattice rectum of the hyperbola? That is basically again same as the ellipse result, that is 2ab square by a for this particular parabola, sorry, hyperbola, and that is basically e times. So if you consider the lattice rectum of, so lattice rectum LR of parabola, so lattice rectum of parabola is basically 4 times of AE. Okay, now it is saying that it is basically is equal to E times the lattice rectum of hyperbola, and that is this particular result. So from here E and E get cancelled, that is eccentricity value get cancelled, and we will have A square as a square, sorry, 2 times of a square is equal to b square. So that is an important implication or result I got from here. So we will get it the result as a 2 times of a square is equal to b square. Now again we also have a condition, that is 2 root 2 comma minus of 2 root 2 passes through, okay, passes through the hyperbola, that is x square by a square minus y square by b square is equal to 1. So from here, if I put in this particular equation, it will be 8 by a square minus 8 by b square is equal to 1. And we also have the condition, that is a square and b square are related as, so this will be equal to 1 plus 8 times, and now in place of a square I put it as 2 times of b square. This will be equal to 4 b square is equal to 1 plus 8 by b square. And from here, if I simplify, the result will be 4 times of b square is equal to, so the result will become, so from here you can simplify the result and you will get the result it as, okay, sorry, a square is basically uh, 1 by 2 times of b square, okay. So this will be 16 times of b square, 16 times of b square. So from here the result will be, 8 times of b square is equal to 1. So the b value will be equal to, so b square value will be equal to 8. So if I have the b square value is equal to 8 and a square will be equal to half times of b square value, that is basically 4. So a square b square I got the value, and if I have the value of a square b square, I can find the eccentricity of the hyperbola as 1 by b square 1 plus b square by a square whole square root. So this will become equal to 1 by 2 square root of it, and that will be equal to root under 3 by 2, and the result will be equal to root under, oh sorry, very sorry, not 3 by 2, oh very sorry, this will be 2 only, all right. So big mistake, okay, 1 plus 2, and that is basically root 3. So the eccentricity will be equal to root 3, and if we have the eccentricity equal to root 3, then the equation of the, then we have the equation of this particular parabola will be y square is equal to 4ae. So a value is basically equal to 2 and e is basically root 3. So the result of the parabola will be y square is equal to 8 root 3x. So that is the equation of the parabola. So y square is equal to 8 root 3x. And if the y square is equal to 8 root 3, then which of the following point lies on this parabola? So it is again, it is asking you to basically check, put this particular points and corresponding check it. Okay, now these types of questions are very important for your JEE Mains, because many times the JEE Mains question, they will give you 4 options and they will ask you which of the following points do satisfy this line or do not satisfy this particular equation. So be very careful while solving this. So with this, if you put the option number B, okay, so you put the option number B, it will definitely satisfy it. As you can see, the 3 root 3 is basically 27, 27 into this 8 root 3 into, and this will be basically 6 root 2, so 6 root 2 root 6 and minus of 48. So this is which is the following point. This is the following point which is basically lying on the this particular following point will lie on the this particular parabola. That is option number B is the right answer. Option number B is the right answer. All right. This is a pretty simple problem. I hope you have understood it. Let us move to the next problem. And the next problem, it is saying that, and the next problem is basically saying that is again an important type of problem, okay. So it is a problem on the which is considering the normal, okay, and also it includes a parabola concept as well. So it is saying that let a tangent to the parabola, okay, so we have the parabola equation as y square to 24x. So it is saying that the tangent drawn to the parabola, okay, so we have a parabola somewhat like this, okay, and if tangents are drawn to the parabola at point alpha and beta, okay, at the point alpha comma beta, so if you consider this is a point alpha comma beta, that is point P, and if tangent is drawn to this parabola at this particular point which is perpendicular to the line, and it is basically perpendicular, so the tangent is drawn such that the tangent slope of the tangent is basically, now if we have this particular line as, so the equation of the line to which the tangent is perpendicular, that is 2x plus 2y is equal to 5. So from here you can see that the equation of the line is basically equal to minus of 1. So if the equation of line is minus 1, then what is the equation of tangent? That will basically equal to 1. Okay. Now what will be the equation of the tangent? So the equation of tangent at P is basically equal to beta y plus 12 times of x plus alpha by 2, 24 times of x plus alpha by 2. So that will become 12 times of x plus alpha. And if we put the slope of this particular line, what will the slope of this line? It is 12x plus 12 alpha minus of beta y is equal to 0. So what will the slope? the slope is basically equal to 12 by minus of 12 by beta, and that is equal to 1. So from here you get the value of beta as minus of 12. Okay, so you get the value of beta as minus of 12, and uh, sorry, actually it will be, oh, very sorry. It will be minus of minus, so that will become plus, because what is the slope? The slope is basically minus times of the coefficient of x and coefficient of y divided by coefficient of y. That is the slope of the straight line. So that will be plus of 12 by beta, and that is basically beta is equal to plus 12. And if beta is equal to plus 12, I have the value of beta. And since alpha beta lies in this parabola, then I can get the value of alpha as well. So the value of x, or basically alpha, is also equal to, is basically equal to 12 square by 24. That is 144 by 24. That is basically equal to 6. Okay, that is basically equal to 6. So alpha value I got it as 6, and beta value I got it as 12. Okay, now it is saying that if the hyperbola, now there is an hyperbola which is basically x square by alpha square minus y square by beta square is equal to 1. Now there is an hyperbola of this particular fashion. Now it is saying that if normals are drawn at the point, so at point, let me write this point as q, and that is alpha plus 4 and comma beta plus 4. So alpha is basically 6 plus 4, that is 10, and beta is basically 12. 12 plus 4 is basically 16. So at point q, if normal, okay, so normal is drawn, okay, so normal is drawn, then, so we know that the equation of a normal for the ellipse, for the hyperbola, is basically opposite, like in the same fashion you can remember, like x into x1 by alpha square. Okay, so that particular fashion you can definitely remember that the equation of the normal will become equal to 36. Okay, because we are drawing it as q, and that will basically 10 comma 16, so it will be a square for the equation of the hyperbola considering x square by a square. So I am writing it result as alpha square x by the x coordinate. So that will be 36 times of x by the x coordinate is basically 10 plus, and what is a beta square? Beta square is basically 144, and 144 y by what is a y coordinate at the point where the normal is drawn is 16 is basically equal to a square plus b square, that is basically 36 plus 144, and 36 plus 144, okay, this will be 180. Okay, this will be equal to 180, and if you simplify, the result will be x by 50 plus, if you simplify, you can definitely simplify this. Okay, this is very pretty straightforward. It is basically 5 times, so this is basically 50 by x by 50 plus y by 20 is basically equal to 1. So that is the equation of the normal. Now it is asking for which of the following point, do not pass. So there is again a hurdle. It is saying that it is the point which do not passes. Okay, do not passes to the point. So if you can go on putting out these options, you will find the option number D does not satisfy this particular equation. So the option number D does not satisfy this equation. Okay, option number D does not satisfy this equation. That means option number D is the right answer to this particular problem. I hope you have got this particular problem. Okay, this was a problem which basically focused on hyperparabola, and then it actually made it to find the hyperbola. So you can see these are the pretty straightforward problems. Okay, but you need to understand the equation of tangent and normal for each of the conic sections. All right, so with this, let us move to the again. So what I actually observed is there are not many questions which are basically asked from the multiple choice. Okay, but you can definitely expect questions from hyperbola. Then definitely there will be questions which basically will contain, okay, which basically must have content the numerical type. Okay, so it is better to, if you look at the numerical type again. So it is saying that it is another important problem. Okay, now it is saying that the vertices of the hyperbola, okay, so we have the vertices of the hyperbola as plus minus 6 comma 0, and its eccentricity, okay, we have the eccentricity, that is eccentricity E is basically 5 root 5 by 2, and let n be the normal to the hyperbola at a point in the first quadrant and is parallel to the line. So the line equation of line is 2 root 2x plus y is equal to 2 root 2. So from here, what I can write, the slope of this particular line, the slope of the line is equal to minus of root 2. That means the slope of the tangent, the slope of the normal, n. So what is the slope of the normal n? That is basically 1 by root 2. That will basically 1 by root 2. Okay, so I have got the slope of the normal, that is 1 by root 2. And if it is saying that d is the length of the line segment n between the edge, okay, length of the line segment n between h and the y-axis is basically d square, then the value of d square is equal to. That is pretty straightforward problem. And if you look at the equation of the, so if you can draw the hyperbola in this particular fashion, because one of the vertices of the hyperbola is 6 comma 0, so you can draw this like this fashion, and it is the point P, why it lies in the first quadrant. And if you draw the normal, so normal will be something like this. So let me draw normal over here. So for point on the first quadrant, okay, so this is a point on the first quadrant, and let a normal be drawn like this, okay, so which is perpendicular. If you draw the tangent at point P and this is a normal, that means you see they are basically perpendicular to each other. And what is said in the question, if D is the length of the line segment n between h and the y-axis, so y-axis is basically the conjugate axis of this particular hyperbola, that is, and this particular point, let me write this point as k, and we have to find for the distance d, this particular distance as d, we have to basically find for the square of the distance d. All right, so this is pretty straightforward problem. And what we think we have to do is basically from the eccentricity equation, that is, we have got to the value of a as 6. Okay, value of a is basically equal to 6, and from eccentricity equation we basically will be getting the equation of the value of b, that is eccentricity is basically equal to 1 plus b square by a square. And if you solve this, you will get the value of 1 by b square by 36 is equal to eccentricity, and the eccentricity value is equal to root 5 by 2. Okay, eccentricity value is equal to root 5 by 2. So if you solve this, you can square both the side. It will be 5 by 4. Okay, it will be 5 by 4. 5 by 4 is equal to 1 plus b square by a square, and a square value is equal to 36. So if you subtract, it will be 1 by 4. So b square by 36 equal to 1 by 4, and if you cancel this, is b is value will be equal to 3. So b value will be equal to 3. All right, so I can definitely write the equation of the hyperbola equation will be x square by 36 minus y square by 9 is equal to 1. Okay, now for any general point on a hyperbola is basically assumed as, okay, so you have to basically get to the point, okay, on the hyperbola, and that particular point is basically assumed as a sec theta comma b tan theta. Okay, a sec theta comma b tan theta, and from this point, if normal is drawn, okay, normal is drawn, the equation of the normal will be basically equal to, so value of a is basically 6. So 6x cos theta by 6x cos theta plus plus, in place of b we have to put 3, and 3y cot theta, 3y cot theta, that will be equal to a square plus b square, that is basically equal to 45. Okay, so that is the equation of the normal. And if we see the slope of the normal, okay, slope of the normal is equal to minus of 2 cos theta by cot theta. So that will basically equal to minus of 2 sin theta, and which is eventually given in the problem as minus of root 2. And if you solve this, you will get the sin theta value as, so sin theta is basically equal to 1 by root 2. So sin theta is basically 1 by root 2, then theta will be equal to 45 degree. So theta's value will be equal to 45 degree. All right. So that means if I have this theta as 45 degree, then the equation of the normal will become equal to, so at point, so the point A will become 6 a sec theta comma b tan theta, and that will be equal to 6 root 2 comma, so 6 root 2 comma, and 3 into tan theta is 45 1, then it is 3. So at point 6 root 2 comma 3, then the equation of the normal will become equal to root 2x plus y is equal to 15 by putting back into the theta value. So if we have this particular equation, and we have to basically find for the y-intercept, that means you say x is equal to 0, so y is basically equal to 15. That means k value is equal to 15. Okay, so what distance we have to find? We have to define the distance of the point P and the point K, that is the K point is basically 0 comma 15. Okay, so you have to find for this particular distance, and what will be the distance is equal to, so if we apply the distance formula, that is d square is equal to 6 root 2 whole square plus 3 minus of 15 whole square. So it will be equal to 144 plus 72, and if you solve it, it will come out as 216. The result will be 216. So with this, the right answer will be 216, and that is the numerical type answer that you must report. All right, so these types of problems are also important. You must remember how to solve these types of problems. Okay, so how did I solve these problems? This is a very straightforward approach to solve these types of similar looking problem. With this, let us move to the next problem. And the next problem is another problem which basically involves both things, hyperbola as well as the ellipse. So it is saying that for the hyperbola, x square minus y square is equal to 1. Okay, and the ellipse. Okay, we have the ellipse by the operator notation E, that is x square by a square plus y square by b square is equal to 1, where a is greater than b and greater than 0, both of them are positive. Okay, and let's say that it is firstly saying that the eccentricity, and these types of problems actually get repeated in examination, because I have seen question involving eccentricity of hyperbola as well as ellipse, and then they are asking you to satisfy this particular equation and then solve for the eccentricity or solve for the unknown condition. Alright, so it is saying the eccentricity of the ellipse is basically reciprocal of the eccentricity of the hyperbola. So eccentricity of the ellipse is basically 1 by eccentricity of the hyperbola. That means, so what will be the eccentricity of this particular hyperbola? So you can see this is the a value and b value, both are equal to 1. So that means this particular eccentricity is basically root 2. So such hyperbola which is eccentricity is root 2 are basically known as rectangular hyperbola. That means the eccentricity of the ellipse is equal to 1 by root 2. Okay, so the eccentricity of the ellipse is equal to 1 by root 2, and we know the eccentricity value for the ellipse is 1 minus b square by a square for this type of values where a is greater than b. Okay, so I got the value like this, and from here I will also get an equation that is a square by b square is equal to 1 by 2. So this is the first equation. Okay, so this is the first equation, and second it is saying that the line y is equal to, so it is saying that the line y is equal to root 5 by 2 x plus k is a common tangent. So there is another question involving common tangent. Okay, so you can see that how important tangents, normal, common tangents are very important, as well as the normal properties as well. So what I can do for common tangent solving, so you can definitely solve this by firstly assume the equation of tangent for of hyperbola of slope m. Okay, so what is the equation of the tangent for hyperbola of slope m? That is y is equal to mx plus minus root under m square minus 1. Okay, and this is the first equation. Let me label this as a first equation. And similarly, the for the same slope for the ellipse, this particular the ellipse. Okay, for ellipse, the equation of the tangent will be of the fashion y is equal to mx plus minus root under a square m square plus minus of b square. Okay, minus of oh, very sorry, not minus. Minus is for hyperbola. Okay, so these types of things get actually confusing between hyperbola and parabola. I hope whenever you are revising, you must keep a note of these tracks. Okay, because in case of normal, you have basically subtract this parameter minus, so you have a minus sign over here. In case of normals, not in case of tangents. Okay, so these are equations of tangents. Okay, so from here you got a second equation, but both of the things are same because they implies a common tangent. That means this only have to basically satisfy the constant part. So if you equate the constant part, that is y square is equal to m, that is equal to a square m square plus b square, and we already have the value of b square is equal to of a square is equal to 2 times of b square. So I can write this as a square is basically 2 times of b square, so this 2b square m square plus b square is basically equal to m square minus 1. Okay, so this will be the equation, and from here I can also do one thing. I can take this on this particular side and 1 on this particular side. The m square value will be equal to 1 plus b square by 1 plus a square, sorry, 1 minus a square. Okay, so this will be 1 plus b square divided by 1 minus a square, 1 minus a square, and that is the value of m square. Okay, now it is saying that the common slope is basically equal to root 5 by 2. That means square of root 5 by 2 will be 5 by 2. Okay, and also a square is basically 2 times of b square. Okay, a square is basically 2 times of b square. So this is 2 times of 1 plus b square is equal to 5 into 1 minus 2b square. Okay, 5 into 1 minus 2b square. So from here if you simplify, okay, or if you simplify in form of a, okay, you can also definitely simplify from here. That is basically 3 is equal to, so this will be equal to 10, and if you take it on this right side, or you can solve it. Okay, and so from here if you solve it, okay, you will get a relation. Okay, that is 10 times of b square. Okay, 10 times of b square and plus of 2b square, that is 12b square. Okay, so from here you can definitely directly write it as 12b square is equal to 3, and from here you get the value of b square is equal to 1 by 4. So if you have b square is equal to 1 by 4, a square is basically 2 times of b square, that is 1 by 2. Okay, so you got the value of a square and b square. Now if you have a square as 1 by 2 and b square as 1 by 4, then you can definitely find out the value, that the numerical value that is the question is asking is basically 4 into a square plus b square is basically equal to 4 into 2 by 4 plus 1 by 4, and that is equal to 3, and that is equal to 3. So with this, the numerical answer will be equal to 3. Okay, so I hope this is a pretty straightforward problem. All right, so I hope you have got this particular problem. Now let us move to the next problem, and this is the next problem, and with this problem I'll basically end. Okay, so I would like to keep this problem free to you, just give it as a homework. Okay, so I would like all of you to basically give a thought on this particular problem. Okay, now this is a very important problem. I will give you a hint. Okay, no, don't worry, I will give you a hint, but I want the answer to be in the comment section. Okay, I want the answer in the comment section as well. Okay, so it is saying that there are the equation of two diameters circle, diameter for circle. Okay, the equation of two diameters of a circle, so there is a circle. Okay, so there is a circle x square plus y square minus 2x plus 2fy plus 1 is equal to 0. So for this particular circle, there are the equation of two diameters. For a circle, there can be infinite numbers of diameter. Now, out of them, the two diameters equation is basically px minus y is equal to 1, px minus y is equal to 1, another diameter. So these are basically diameter. Okay, diameter, and other diameter is 2x plus py. Okay, so the second diameter, let me write it properly, plus py is equal to 4p. Okay, these are the two diameters. So from solving this two diameter, we'll basically get the center. So if you can solve this two diameter, you will get the center. And if you get the center of the circle, you can also write the center of the circle from here. From the equation of the center of the circle, it will be 1 comma minus of f. So from here, you will basically get the value of f. Okay, you can solve for the value of f in terms of p. Okay, you can solve for the value of f in terms of p. Now it is saying that the slope m, where slope m belongs from 0 to infinity, that is basically positive slope of the tangent of the hyperbola, that is x square minus y square by 3 is equal to 1. So for this particular hyperbola, okay, for this particular hyperbola, the tangent which has a slope, positive slope, and passing to the center, and this tangent, okay, so if you satisfy that equation of the tangent, this particular equation of tangent, that is a square m square minus b square. So from here, if you satisfy the equation, and this will satisfy to the center coordinate, so from here you basically will get another equation involving the point p. Okay, since it passes through, and it is saying that it passes through uh, the tangent passes to the center of the circle. So circle center, you basically get it as from by solving this particular, and then it passes to center, then you basically get to the value of m. So if you have the value of m, and you basically need to represent the slope of the slope of the tangent, so you basically have to report me the value of our m. So what will the value for m? Okay, that is basically asking the problem. Okay, so I hope you can definitely solve this problem with this particular hint. Okay, so I will be waiting for your comments in the comment section. So with this, I come to the end of this today's important session for the discussion of the hyperbola. Okay, and yeah, so that was my take on the top 10 important problems on hyperbola. So as you can see, the hyperbola problem is not very difficult, but if you have studied the entire chapter of hyperbola, including the straight lines, including the from the straight lines to the hyperbola, if you have studied it nicely with all the properties, everything in detail, then you can definitely solve any question on conic section. And you can assume that for conic section, the weightage will be like, you can assume like there will be like at least 4 or 5 question at max from conic section. Okay, so that means that will make the weightage as basically plus 20. Okay, so that is making you the weightage of conic section as plus 20 marks. Okay, so that is a like a good contribution for the chapter of this particular 5 chapters. Okay, I hope you have understood all these particular things, and now I will basically mention you what things you have to basically remember. For conic section, I will always say that you will basically need to memorize the tangent normal equation. Okay, equation of tangent normal. Okay, and the important properties. Okay, important properties, I will write it as important properties. Okay, now for the entire conic section, these things will be basically important properties. Now since what is basically, so important properties. Okay, the spelling is wrong. All right, So important properties of this entire conication part. Okay, just these things are very important. So for straight line part, I will say you have to basically look out the different equations and the important properties like the reflection concept, the concept for finding the perpendicular distance, the concept of finding the image of a point about the straight line as a mirror. Okay, and for circle you basically need to remember those particular formulas for tangent in different format, how to take the parametric form. Okay, and also three important things is chord with a given midpoint and chord of contact, and also the pair of straight tangents, and as well as the family of circles. And similarly for parabola, hyperbola and ellipse, you basically need to look at the important properties. By important properties I mean the general discussion of the parabola, hyperbola and ellipse, like eccentricity, what is the minor axis, major axis, for hyperbola conjugate axis, transverse axis, and finding the vertices, foci and eccentricity. For parabola it is the focus, directrix. Okay, and the important properties by mean the different geometrical properties, and based on which the questions are also asked in the paper. All right, so I hope you will understand and solve this particular on your own. Okay, so with this I came to the end, and thank you.